Very good morning, friends. In this video, we are going to learn how to draw the projections of a pentagonal lamina when it is resting on one of its sides on HP with the corner opposite to that is at a given height from the HP. In this problem, it is not specified what is the angle made by the surface of the lamina with HP. We will go through the question for today's video. The question reads like this. A pentagonal lamina of side 30 rests on HP. On one of its sides, it got 5 sides. So it is resting on one of the sides, which is at a distance of 10 mm VP. The side which is on HP is at a distance of 10 mm from the VP, the board. Draw its projections when the corner opposite to that side on which it is resting is 25 mm above HP. And this is the question. Here, I have given the instruction in most of the previous videos on the laminae or the plane surfaces that whenever a lamina has to rest on one of its sides on HP, you have to place the lamina on HP such that the one of the sides of that lamina is normal to VP, and it is normal to VP or perpendicular to VP, and obtain its projection. Friends, here I have constructed a regular pentagon ABCDE of side 30 with the side AB perpendicular to VP. So friends, you know very well that whenever a lamina is resting on HP on its surface, in the front view, you see the lamina as a line irrespective of the angles made by any of the sides of the lamina. So it is very obvious I am going to get a line here which is represented by A dash, B dash, D dash by projecting all these points, and we obtain the front view. So front view is seen as a line A dash, D dash on which you have got 5 points, and hence it represents a pentagonal surface. Now friends, let us say the distance of this corner D from AB is equal to m. M can be measured using a scale. Now what does he say, friends? The lamina is resting on HP on one of the sides, and the corner opposite to that is D. Now it is resting on AB. The corner opposite to that is D, that is on HP. But when you tilt it about this edge, it should go to a height of 20 Hence, I am going to draw a line here, which is called the locus of that corner D, which is at a height of 20 This is done by drawing a horizontal line parallel to XY at a distance of 20 Now, you know friends, in all the solids and the laminae, figure number 1 and figure number 2 in the front view, they are exactly identical. So this is figure number 1 and this is figure number 2 here. They are exactly identical. So what do? I take some point A dash B dash at random on XY, taking that point as the center and radius equal to m. I just make an arc or draw an arc with center A dash B dash and radius is equal to m, which I have shown here. Friends, you obtain or join this B dash to A dash B dash, and this line in the front view represents the front view of the lamina when the corner opposite to the side AB is at a height of 20 And after obtaining this front view, we need to draw the top view corresponding to that. Friends, what happens? Again, you are going to get a pentagon which is not a regular pentagon. It has to be necessarily a distorted pentagon. How to get them? Draw a vertical line from A dash, a horizontal line from A. The point of intersection will give you A. Likewise, draw a vertical line from B, a horizontal line from B here, they meet at this. And remember friends, since the side AB is perpendicular to VP, the length of this line will remain the same as 30. And friends, similarly obtain point C, D and E. Now to obtain C, a vertical line from C dash, a horizontal line from C here, the point of intersection will give you the point C. D, vertical line from D dash, horizontal line from here, the point where those two intersect is point D. And finally, E lies on this line drawn through the point E. So this is how the lamina looks when the corner opposite to the side AB is at an angle. And friends, now you can easily measure what is theta. Theta means the angle made by the surface with the HP, that can be measured, and I call this as theta. Now friends, finally, the question is says draw its projections when the corner opposite to that side is 25 mm above HP. It is not 20, it is 25. Doesn't matter. 25. So friends, what do we do now? We have this top view and we are going to redraw this top view such that one of the sides is at a distance of 10 millimeter from VP. So I am going to write a horizontal line here at a distance of 10 millimeter from the wall, from the VP. And here I am going to redraw this figure number 3 as figure number 4. So these two are exactly identical excepting for the orientation of the sides. So what I do, I construct this figure here keeping AB, the line AB or the edge AB on this line which is at a distance of 10 millimeter from VP and obtain the final front view. So friends, this figure will give you the top view which is the photocopy of this figure number 3 and obtain points one by one. Follow the same procedure. So to get point A here, draw a vertical line from A here, a horizontal line from here, they meet at this point and I call it as A dash. Similarly, vertical line from B, horizontal line from B dash, they meet at this point, so we will call it as B dash. Similarly, C, vertical line from C, horizontal line from C dash, meet at this point, so we get C dash. Similarly, E dash and E, and finally exactly in the center of this, you are going to get D dash. And friends, this is how we obtain the final front view and top view of the lamina which is resting on HP on one of the sides. And before we conclude this session, we should verify whether the solution, that is the projections of the lamina we have got, are correct or not. So how to verify? Friends, it has to rest on one of the sides on HP. Yes, it is resting on side AB on HP. Since it is on HP, its front view is seen as a line on XY, A dash, B dash. And that side AB on which it is resting on HP is at a distance of 10 millimeter. That you can see. It is at a distance of 10 millimeter. And finally, the corner opposite to the side on which it is resting, that is, the side on which it is resting is A dash, B dash, and that has to be at a distance of 25 millimeter above HP. Yes, you can see D is at a distance of 25 in this view, again in this view. So the solution we have got for this problem is totally correct. Friends, I hope the presentation was interesting. Please go through the complete video without skipping any part of the video. And if you like this video, do share with all your friends without fail. Thank you friends for watching my YouTube video.